at your hand. See the delicate tracery of veins beneath the skin, the faint blush of life. Every atom in that hand, the carbon, the oxygen, the iron in your blood that carries the breath of life, was forged in the heart of a star that died billions of years ago. You are, in the most literal sense, stardust. You are a child of the Milky Way. Our galaxy is our grand cosmic parent, a swirling city of light, home to 400 billion stars, and we live on a quiet, dusty lane in one of its spiral arms. Yet, for all its parental intimacy, this home of ours is a place of profound and beautiful secrets. We look up at its gentle, shimmering river across the night sky, and we feel a sense of belonging. But what if I told you that everything we see, every star, every nebula, every grain of dust, accounts for less than 15% of the galaxy's true mass? What if our home is mostly made of nothing we can see? A whispering ghost holding it all together. This is just one of its secrets. Before we begin our journey into the quiet heart of these mysteries, we would be so grateful if you would join our community. A gentle tap on the subscribe button and the bell icon ensures you won't miss our future explorations. And if you find a moment of peace or wonder here, please consider liking this video and sharing this quiet corner of the cosmos with someone you know. Thank you. Now, find a comfortable space. Let your mind settle, and let us begin. The River of Heaven. For as long as we have been human, we have looked up. From ancient campfires, our ancestors gazed into the deep velvet dark and saw a faint, luminous band stretching from horizon to horizon. They saw a path, a river, a celestial spine. Different cultures gave it different names. The Greeks called it Galaxias Kyklos, the Milky Circle, a name that has stayed with us through the millennia. In East Asia, it was the Silver River, a heavenly stream separating two celestial lovers. This river of light is our home, the Milky Way. It is a barred spiral galaxy, a vast spinning disk of stars, gas, and dust. From our vantage point, nestled within one of its arms, we see it edge on. That beautiful, hazy band is the light of billions of distant, unresolved stars, all blending into a single collective glow. It feels familiar. It is a constant in our sky, a map for our seasons, a source of our myths. And yet, the more we learn, the more we peer into its depths with our incredible instruments, the more we realize how little we truly know. It is like living in a house your entire life, only to discover it has countless hidden rooms, secret passages, and a foundation built on principles you are only just beginning to grasp. In our journey together tonight, we will not be conquering these mysteries. We will not be solving them with brute force. Instead, we will approach them as one might approach a sleeping animal, with reverence, with quiet curiosity, and with a profound sense of awe. We will wander through 12 of the galaxy's most beautiful, unanswered questions. We will explore the invisible structures that hold it together, the dynamic forces that give it life, and the deep, lingering questions about our own place within this cosmic island. So, let your breath slow. Allow the world outside to fade away. We're about to drift down that silver river to listen to the soft, ancient whispers of the Milky Way. The invisible architecture. Our galaxy is an immense structure, a cosmic metropolis of breathtaking scale. But like any great city, its most important infrastructure is often hidden from view. The foundations, the power grid, the unseen forces that allow everything to function, these are the deepest secrets. Our first set of mysteries concerns this invisible architecture, the silent scaffolding upon which the entire galaxy is built. The whispering ghost, the enigma of dark matter. Imagine a carousel spinning merrily. The horses on the outside must travel a much greater distance to complete a circle than the ones near the center, so they must move faster. But in a system held together by a central point of gravity, like our solar system, the opposite is true. The farther out you go, the weaker the gravitational pull and the slower you must orbit. Mercury zips around the sun, while distant Neptune plods along on its immense slow journey. For decades, we assumed our galaxy worked the same way. Stars far from the galactic center should orbit more slowly than stars closer in. But when the pioneering astronomer Vera Rubin pointed her telescopes at the edges of galaxies, she found something that was, and remains, utterly bewildering. The stars on the outer fringes were moving just as fast as the stars farther in. This should be impossible. A carousel spinning this way would fly apart. The stars at the edge are moving so quickly that the gravity from all the visible matter, all the stars, gas, and dust we can see, is not nearly strong enough to hold them in their orbits. They should have been flung off into the intergalactic void billions of years ago. And yet, here they are. Our galaxy is stable. The only way to explain this is if there is something else there, something massive, something that doesn't shine or reflect light or interact with us in any way we can currently detect, a vast invisible halo of something. We call it dark matter. Think of it like the wind rustling the leaves of a tree. You cannot see the wind itself, but you can see its effect on the leaves. In the same way, we cannot see dark matter, but we see its gravitational effect on the stars. It is the silent, invisible mass that provides the extra gravity needed to bind our galaxy together. It is a whispering ghost, its presence felt everywhere, but its nature remains one of the greatest mysteries in all of science. It makes up nearly 85% of the matter in the universe, and we are floating through a sea of it, completely unaware, like fish who do not know they are in water. The sleeping giant, the supermassive black hole, Sagittarius A. At the very heart of our galactic city lies a point of extreme gravity and profound mystery. It is a place of such immense density that nothing, not even light, can escape its grasp. This is Sagittarius A*, pronounced A star, our galaxy's supermassive black hole. For years, its existence was only inferred. We watched stars at the galactic center behaving strangely. They were whipping around an apparently empty point in space at incredible speeds, some completing an orbit in just a handful of years. The only thing that could command such loyalty, that could swing entire stars around like a cosmic slingshot, was a black hole of unimaginable mass. In this case, 4 million times the mass of our own sun, all compressed into a space smaller than the orbit of Mercury. In 2019, the Event Horizon Telescope collaboration gave us our first glimpse of this giant, or rather, its shadow. A ring of blazing, superheated gas swirling around a perfect circle of pure blackness, the point of no return. But the mystery is not just that it exists. The mystery is how. How does such a colossal object form? Did a single gigantic star collapse in the early universe, slowly feeding on its surroundings for billions of years? Or did countless smaller black holes born from the first generations of stars spiral together and merge into the behemoth we see today? And what is its role? Is it a destructive force, a cosmic drain, or is it a creative one? The intense energy pouring from the region around Sagittarius A star may regulate star formation throughout the galaxy, acting as a kind of galactic thermostat, sometimes triggering bursts of new stars, and other times blowing away the necessary gas and quenching their birth. It lies there, 4 million solar masses of silent, sleeping potential, 26,000 light-years away, a sleeping giant at the heart of our home whose origins and ultimate purpose we are only just beginning to question. The woven heart, the nature of the galactic bar. If you could float high above the Milky Way and look down, you wouldn't see a simple, graceful spiral like a pinwheel. Instead, you would see that the spiral arms do not emerge from the center itself, but from the ends of a vast, elongated structure of stars, a bar. Our galaxy is a barred spiral. This central bar is a dense, cigar-shaped collection of mostly older, redder stars, stretching tens of thousands of light-years across the galactic core. It is a colossal, rotating structure, and we are only now beginning to appreciate its profound influence. The mystery here is twofold. First, how did it form? Was it always there, a feature born from the galaxy's initial collapse? Or did it form later, as the gravitational interactions of the stars in the central disk created an instability that grew and organized itself into this immense shape? Think of it like stirring cream into coffee. At first, it's chaotic, but soon patterns and swirls emerge. The galactic bar may be just such an emergent pattern, a grand piece of self-organization on a cosmic scale. And what does it do? We believe this bar acts as a great cosmic river, funneling enormous quantities of gas and dust from the spiral arms inward toward the central region. It is a celestial conveyor belt, delivering the raw materials for new stars, and perhaps feeding the sleeping giant Sagittarius A. It might be the primary engine that shapes the evolution of the galaxy's core. Our own sun is located at an angle to this bar, and its gravitational influence gently tugs on our orbit. We live within its far-reaching field, its silent, organizing force, shaping the very flow of our galactic home. Understanding its birth and its life is key to understanding the life of the Milky Way itself. The lopsided disk. The galactic warp. Imagine a vinyl record spinning perfectly flat on a turntable. For a long time, this is how we pictured the disk of our Milky Way. But the reality is far stranger and far more beautiful. If you trace the galaxy's disk of stars and gas, you'll find that it's not flat, it's warped. On one side of the galaxy, the disk bends gently upwards, and on the other side, it bends downwards. It looks less like a flat plate and more like a vast, spinning, corrugated sheet or the brim of a slightly crumpled hat. What could cause such a colossal distortion? The entire structure of our home bent out of shape. There are several beautiful theories, each one a mystery in its own. Perhaps it is a gravitational memory. Billions of years ago, a smaller satellite galaxy may have passed through our disk, Like a stone dropped into a still pond, it would have sent ripples propagating outwards, and the warp we see today is that ancient ripple still echoing through the fabric of the galaxy. Another idea points to our neighbors, the Large and Small Magellanic Clouds, two dwarf galaxies that orbit the Milky Way, are gravitationally bound to us. Their constant, powerful tugging, like a child pulling on the edge of a tablecloth, could be the source of this gentle galaxy-spanning warp. Or perhaps it is an interaction with the invisible. The immense halo of dark matter surrounding our galaxy may not be perfectly spherical. If the halo itself is misshapen or lopsided, its gravitational influence could be twisting the luminous disk of stars embedded within it. Whatever the cause, this gentle warp tells us that our galaxy is not an isolated island. It is a living, breathing entity interacting with its environment, shaped by its history, and forever in a delicate dance with the forces, both seen and unseen, that surround it.
The cosmic garden. A galaxy is not a static object. It is a dynamic, evolving system. It is a cosmic garden where new stars are born like seeds, where planets bloom, and where the conditions for life might, just might, be cultivated. Our next set of mysteries explores the galaxy as a living place, a place of creation, potential, and one very profound silence. The celestial nurseries. The inefficiency of star birth. In the beautiful, swirling arms of our galaxy lie vast, cold, dark clouds of gas and dust. These are the nebulae, the stellar nurseries. They are some of the most stunning objects in the cosmos, places where gravity is slowly, patiently gathering material together to form the next generation of stars and planets. They are the wombs of the galaxy. From a distance, they look serene and productive, but up close, they are surprisingly inefficient. Here's the puzzle. These clouds contain more than enough raw material, dense hydrogen and helium, to form hundreds of thousands or even millions of stars. Based on our understanding of gravity, these clouds should be collapsing under their own weight and producing stars at a furious rate. But they don't. The rate of star formation in the Milky Way is surprisingly slow and measured. Only about 1% of the gas in any given molecular cloud will actually end up in a star. The rest is simply blown away. Something is holding back the process. Something is preventing the garden from becoming overgrown. What is this regulating force? It could be turbulence. The gas within these clouds is not still. It's a maelstrom of swirling eddies and chaotic flows that can prevent gravity from taking hold. Or it could be magnetic fields. These fields, invisible but powerful, thread through the clouds and can act like a supportive scaffold, holding the gas up against gravitational collapse. Perhaps the most poetic answer is that the stars themselves are the regulators. The very first massive stars to ignite within a cloud unleash powerful stellar winds and intense radiation. This first burst of life is so energetic that it blows away the remaining gas, effectively sterilizing the nursery and preventing its siblings from being born. It is a form of self-regulation, ensuring the galaxy doesn't burn through all of its fuel too quickly. Understanding this delicate balance between the pull of gravity and the forces that resist it is to understand the very pulse of the Milky Way's life. The Goldilocks Zone, Galactic Edition. The habitable zone. We are all familiar with the concept of a star's habitable zone, the Goldilocks region where a planet is not too hot and not too cold for liquid water to exist on its surface. Earth sits comfortably within our Sun's habitable zone. But there may be another, much larger habitable zone, a galactic habitable zone, an entire region of the Milky Way that is just right for the development of complex life. Think about it. If you are too close to the galactic center, the environment is extremely hostile. The density of stars is immense. Supernovae, the explosive deaths of massive stars, are far more common, bathing nearby planets in lethal radiation. The gravity of the central black hole and the dense bar could disrupt planetary orbits. It's a beautiful but dangerous downtown. If you are too far out, on the galaxy's remote frontiers, you have a different problem. The stars there are metal-poor. In astronomy, metals are any elements heavier than hydrogen and helium. These heavier elements, the carbon, oxygen, silicon, and iron needed to form rocky planets and, indeed, life, itself are forged in stars and scattered by supernovae. In the outer regions of the galaxy, there haven't been enough generations of stars to enrich the environment. You have the peace and quiet, but you lack the basic building blocks for a world like Earth. So there might be a sweet spot, a broad, donut-shaped ring in the galaxy, far enough from the core to be safe, but close enough to be rich in the elements of life. Our Sun and our Earth happens to reside right within this proposed galactic habitable zone. Is this a coincidence, or is our very existence evidence that such a zone is real? And if it is real, how wide is it? How stable has it been over billions of years? This concept frames our existence not just in relation to our star, but in relation to our entire galaxy, suggesting that our dress is just as important as our house. The Great Silence. The Fermi Paradox in our backyard. This leads us to one of the most profound and humbling mysteries of all. Our galaxy is ancient. It is vast. It contains up to 400 billion stars. We now know that planets are the rule, not the exception. Many of these planets lie within their stars' habitable zones. Many will be in the galactic habitable zone. If even a tiny fraction of these worlds developed life, and a tiny fraction of that life became intelligent and technological, the galaxy should be teeming with civilizations. Some would be far younger than us, but many would be far, far older, millions or even billions of years more advanced. Given that much time, a civilization should be able to spread across the galaxy, or at the very least, send out signals or probes. The galaxy should be noisy. It should be full of radio chatter, evidence of astro-engineering projects, blinking lights. But yet we hear nothing. We see nothing. There is only a great cosmic silence. This is the Fermi Paradox. Where is everybody? There are countless possible and equally unsettling solutions. Perhaps complex life is far rarer than we imagine. Perhaps the leap to intelligence is the great barrier. Perhaps technological civilizations inevitably destroy themselves. Or perhaps they are out there, but they are deliberately hiding, observing us from afar, adhering to some cosmic prime directive. Or maybe the answer is more serene. Perhaps they have moved beyond physical communication, existing in realms we cannot yet perceive. Perhaps the galaxy is not a void to be filled with chatter, but a sanctuary to be contemplated in silence. We have only been listening for a tiny fraction of a cosmic second, but for now, the silence from our 400 billion neighbors is a deep, echoing mystery that speaks directly to our own solitude and our own significance.
The cosmic rain, the origin of high-energy cosmic rays. Our planet is constantly being bombarded by a gentle, invisible rain. It is not water, but a shower of subatomic particles, protons, atomic nuclei, traveling at nearly the speed of light. These are cosmic rays. Most of them are low-energy particles originating from our own sun, but a very small, very special fraction of them are astonishingly powerful. A single one of these ultra-high energy cosmic rays can carry the kinetic energy of a baseball thrown at 100 miles per hour, all packed into a single, invisible proton. What in our galaxy could possibly act as a particle accelerator powerful enough to create such a thing? The prime suspects are supernovae. When a massive star dies, the resulting shock wave could, in theory, accelerate particles to these incredible energies. The particles would be bounced back and forth across the shock front, gaining speed with each pass, like a cosmic surfer riding a wave before being flung out into the galaxy. But our models of supernovae struggle to explain the very highest energies we observe. So, we look for more exotic sources. Perhaps they come from the turbulent, magnetized environments around pulsars, the rapidly spinning, dense remnants of dead stars. Or maybe they are fired from the jets of material being ejected from the vicinity of stellar mass black holes. Some even point to the greatest engine of all, the supermassive black hole at our galactic center, Sagittarius A. These particles travel for millions of years, their paths scrambled by the galaxy's magnetic fields. So by the time they arrive at Earth, their point of origin has been completely erased. They are like messages in a bottle, washed up on our shores with no return address. Unlocking their source would reveal the most powerful and violent engines hidden within our otherwise peaceful-looking home. In-depth exploration, the unseen and the unfathomable. Let us now take a moment to drift deeper into two of the most foundational mysteries we have touched upon. To truly feel their weight, we must give them our quiet, focused attention. We will explore the vast, invisible ocean of dark matter, and then journey to the very edge of understanding at the Everton horizon of our galaxy's heart. A deeper dive into the ghost, the search for dark matter. We have said that dark matter is like the wind. We see its effects, not its form. But this simple analogy belies the sheer depth of the puzzle and the beautiful, creative ways humanity is trying to solve it. For decades, the search for the dark matter particle has been one of the great quests of modern physics. Imagine you are in a completely dark room. You know there is furniture in the room because you keep bumping into it. It obstructs your path. That is our situation with dark matter. We have bumped into it gravitationally. We see it in the spinning of our galaxy. We see it in the way light from distant galaxies is bent as it passes through the Milky Way's halo, a phenomenon called gravitational lensing. The light is bent more than the visible matter can account for. The invisible mass is there, acting like a lens. So what could it be? Scientists have imagined a whole menagerie of ghostly particles. For a long time, the leading candidate was a class of particles called WIMPs, which stands for Weakly Interacting Massive Particles. Massive because they need to have enough gravity to do the job, and weakly interacting because they barely notice normal matter. They would pass through you, through the entire Earth, as if it were empty space. To find these WIMPs, scientists have built some of the most serene and quiet experiments on Earth. They go deep underground, to the bottom of old mines, to shield their detectors from the cosmic rays we just discussed. In this profound quiet, they build vats of supercooled liquid xenon or germanium crystals. The hope is that out of trillions upon trillions of dark matter particles passing through the Earth every second, just one might, by a sheer fluke, bump into the nucleus of one of their atoms. This tiny collision would create a minuscule flash of light or heat, a single lonely signal of the vast invisible world around us. For years, these experiments have listened in the deep, silent earth, and they have heard nothing. The profound silence from these detectors has led scientists to wonder if they are looking for the right thing. So new ideas are blooming. Perhaps dark matter is not a WIMP, but a different kind of phantom, a particle called the axion, which is incredibly light and would behave less like a single particle and more like a gentle, coherent wave washing through the galaxy. To find it, scientists are building experiments that are essentially very sensitive, very quiet cosmic radios, tuned to listen for the faint hum that this axion wave might produce as it passes through a powerful magnetic field. The search for dark matter is a testament to human patience. It is an exercise in listening to the deepest silence, hoping to hear a single faint whisper that could explain the structure of our entire home. It is a reminder that the most fundamental components of our universe may be the most humble and the most shy, forever eluding our gaze, but always holding us in their gentle gravitational embrace. A deeper journey to the heart, contemplating Sagittarius A. Now let us travel together in our minds to the edge of the abyss. Let us journey 26,000 light-years to the galactic center and approach the sleeping giant Sagittarius A. As we get closer, the sky becomes thick with stars, a brilliant, blazing fog of light. The gravitational forces here are immense, and time itself begins to behave differently. According to Einstein's theory of general relativity, strong gravity warps not just space, but time. Here, close to the black hole, time would run slightly slower for us than for a friend watching from the safety of Earth. The river of time, which feels so constant to us, becomes a sluggish current near this immense object. And what lies beyond the event horizon, the point of no return?
We are now approaching the event horizon. This is not a physical surface. It is a boundary of information, a one-way door in space-time. It is the point where the gravitational pull becomes so strong that the escape velocity exceeds the speed of light. It is the literal point of no return. The ring of light we see in the famous image is not the black hole itself. It is the photon ring, a region where light is so bent by gravity that it can orbit the black hole. We are seeing light that has been trapped in a cosmic dance, circling the abyss. Inside that ring is the shadow, the region of space from which no light can reach us. It is a perfect silhouette against the backdrop of the universe. What lies beyond that horizon? Our laws of physics, as we currently understand them, break down. They can no longer describe the conditions. At the very center, theory predicts a singularity, a point of infinite density and zero volume, where all the 4 million solar masses are crushed into nothing. But this idea of a singularity is likely a sign that our theories are incomplete. It is a placeholder for a deeper truth we have yet to uncover. What really happens inside a black hole is perhaps the ultimate mystery, forever shielded from our direct observation by the event horizon. To float here, at a safe distance, is to be in the presence of the profound. It is to witness the absolute limit of our current knowledge. Sagittarius A* is not just an object, it is a philosophical statement. It is a reminder that there are places in our own galactic home that are fundamentally unknowable to us. It is the universe's way of telling us that some secrets are kept. And so we gaze at its shadow, this perfect circle of black, and we don't feel fear, but a deep, calm, and humbling awe. It is the quiet, still heart of our swirling, chaotic galaxy, a point of absolute silence and mystery around which our entire existence revolves. Our past, our future, our place. Having explored the hidden architecture and the living processes of our galaxy, we turn our gaze to questions of time and belonging. These mysteries concern our history, our future, and the very structure of our local cosmic family. They ask, how did we get here, and where are we going? The missing siblings, the satellite galaxy problem. The Milky Way is not alone. It is the dominant member of a small cluster of galaxies called the local group. Like a great matriarch, it is attended by a host of smaller dwarf galaxies that orbit it. We have discovered dozens of these satellite galaxies like the Magellan Clouds, faint smudges of light held in our thrall. Here is the mystery. Our best models of cosmology, the ones that include the behavior of dark matter, predict that there should be far more of these satellite galaxies. When we simulate the formation of a galaxy like the Milky Way, we see a large dark matter halo forming, but it isn't smooth. It's lumpy, filled with thousands of smaller subhalos. Each of these subhalos should have been a seed, attracting gas and forming a dwarf galaxy. Our models predict that the Milky Way should be surrounded by hundreds, if not thousands, of small satellite galaxies. But we've only found about 50. Where are the others? This is known as the missing satellites problem. There are several gentle possibilities. Perhaps our simulations are wrong. Maybe at these smaller scales, dark matter behaves in a way we don't understand, preventing the formation of tiny galaxies. Or perhaps the galaxies are there, but they are simply too faint for us to see. Perhaps they are dark galaxies, clumps of dark matter that managed to form, but for some reason failed to attract enough gas to ignite any stars. They would be completely invisible siblings, orbiting us in the dark, their presence only detectable by their faint gravitational pull on things we can see. In recent years, we have found some ultra-faint dwarf galaxies, which lends some support to this idea. We may simply not have had powerful enough eyes to see our full family. The family portrait is incomplete. The ancient bones, the formation of the Milky Way. How was our galaxy born? How did this magnificent structure of 400 billion stars come to be? We can look at other galaxies at different stages of their lives, and we can look at the oldest stars in our own galaxy to piece together the story, but the earliest chapters are lost to time. The leading theory is a beautiful one of hierarchical formation. In the early universe, there were no giant galaxies. There were only small, irregular lumps of dark matter and gas. Over billions of years, these small lumps gravitationally attracted each other. They collided, they merged, they danced together in a grand, chaotic ballet. Our Milky Way was built piece by piece from the cannibalization of countless smaller galaxies. It is a collage, an amalgamation of ancient streams of stars.
We can see the evidence for this in our galaxy's halo. As we look at the motions of stars, we can identify stellar streams, long, faint rivers of stars that all move together. These are thought to be the shredded remains of dwarf galaxies and star clusters that were torn apart by the Milky Way's gravity long ago. They are the fossilized bones of the galaxies our home consumed to grow to its present size. The mystery lies in the details of this process. What were the biggest mergers? When did they happen? A recent discovery suggests that a major collision with a galaxy nicknamed Gaia Enceladus about 10 billion years ago was a formative event, shaping much of the galaxy's halo and thick disk. By studying these ancient stellar streams, we are doing a form of galactic archaeology, unearthing the ruins of lost worlds to write the autobiography of our home.
The cosmic collision, the inevitable merger with Andromeda. Our galaxy is moving. Our entire local group is hurtling through space. But within our group, there is another, more intimate motion. Our nearest large spiral neighbor, the Andromeda Galaxy, is moving towards us. Located 2.5 million light-years away, Andromeda is slightly larger than the Milky Way. And through careful measurements of its motion, we have confirmed that it is on a direct collision course with us. There is no need for alarm. This cosmic event will not happen for another 4.5 billion years, but it is, for all intents and purposes, inevitable. What will this look like? It will not be a crash of solid objects. The space between stars is so vast that direct star-on-star collisions will be exceptionally rare. Instead, it will be a gravitational dance of breathtaking scale and beauty. Over millions of years, the two galaxies will first pass through each other. Their spiral structures will be torn apart by immense tidal forces, flinging long streams of stars and gas out into space. They will separate, then be pulled back together by their mutual gravity for a second, and then a third pass. With each pass, they will merge more completely. The chaotic gas clouds will collide and compress, triggering a spectacular burst of star formation, lighting up the new combined galaxy. After hundreds of millions of years of this dance, things will settle down. The two spiral galaxies will be gone, replaced by a single giant and more uniform elliptical galaxy, which some astronomers have already nicknamed Milky Way. Our Sun will likely be flung into a new, different orbit within this new galaxy. The night sky of any future inhabitants of Earth will be transformed. This mystery is not one of what, but of when, and of the unimaginable beauty of cosmic creation and transformation that will unfold long after we are gone. Mystery 12. The chemical anomaly, the lithium problem. Our final mystery is subtle but deep. It concerns the chemical fingerprint of the universe and a nagging discrepancy in our own cosmic backyard. According to our model of the Big Bang, we can predict with incredible precision the amounts of the lightest elements that should have been created in the first few minutes of the universe. The predictions for hydrogen and helium are spectacularly successful. They match what we observe in the oldest stars of our galaxy perfectly. But there is a problem with the third element, lithium. The theory predicts that a certain amount of lithium-7 should have been created. But when we look at the atmospheres of the most ancient, metal-poor stars in the Milky Way's halo, we find only about 1/3 of the predicted amount. Where did the rest of the lithium go? This is the cosmological lithium problem.
Did our theories of the Big Bang get something subtly wrong? This seems unlikely, given how well they work for everything else. A more likely solution lies within the stars themselves. Perhaps the ancient stars, in their youth, had processes that we don't fully understand, which destroyed the lithium at their surfaces. Maybe the lithium was mixed down into the hotter interiors of the stars and burned up. The chemical composition we see today might not be the pristine original composition. The stars themselves might have tampered with the evidence. This mystery is a quiet one. It doesn't involve grand structures or cosmic collisions. It is a subtle chemical whisper from the dawn of time. But it is a profound reminder that even the smallest details, the faintest chemical signatures in the oldest stars of our home, can hold a deep puzzle that challenges our understanding of the universe's very beginning. Conclusion. An invitation to wonder. We have drifted down the Silver River. We have stood in the quiet presence of 12 of its deepest mysteries. From the invisible ghost of dark matter that holds us together, to the silent, sleeping giant at our core. From the inefficiency of the stellar nurseries to the profound silence from our neighbors. From the forgotten bones of galaxies past to the promise of a grand merger in our distant future. What have we learned on this journey? Perhaps the most important lesson is not a fact, but a feeling. It is the feeling of deep connection and of profound humility. Our home is so much grander, so much stranger, and so much more mysterious than we could have ever imagined. We are not separate from these mysteries. We are woven into them. The dark matter we seek flows through us. The elements forged in stellar nurseries and supernovae make up our bodies. The gravity of the central black hole and the galactic bar gently guide our long, slow dance around the galaxy. The mysteries of the Milky Way are not problems to be solved in a hurry. They are invitations. They are invitations to wonder, to be curious, to be patient, and to look up at that faint, milky band in the night sky with new eyes. When you see it next, know that you are not just looking at a collection of distant lights. You are looking at the architecture of your own cosmic origins. You are seeing a living, breathing garden, a place of creation and transformation. You are gazing into a profound silence that asks the biggest questions of all. And you are seeing a home that, for all its secrets, holds us and has held us for the entirety of our existence. The search for answers will continue. Humanity, in its insatiable and beautiful curiosity, will continue to build new eyes, new ears, and new ways of listening to the whispers of the cosmos. But the mysteries may always remain, not as a sign of our ignorance, but as a perpetual source of awe, a quiet reminder that the most beautiful journey is the one with no final